So I think the easiest way to share that is to go in each contract, just globally to explain the whole structure. We will for now 3 contracts. So the first one is the TalentLayer ID. So it's like the first step in the protocol. It's an NFT contract, the point of entry of the whole system. So here, so just to be precise, it's a ERC 721A. So it's a type of NFT contract which is more optimal for gas usage. So it costs not much for user to mint it, like 10 times less than a classic ERC 721. Just to start with the main function, and we can go to the specific one then. So we've got 2 types of mint here. So the first one here is the mint with proof of humanity. Proof of humanity, it's another protocol with a main idea to check that a user is real and his wallet is really linked to him. So we implemented that and let it optional for everyone to mint it without or with him. The only check it requires behind it's just here to call the proof of humanity registry and check if the message sender is really registered yet. So with that information, we then add some stuff in the front end to show user who are already proof or not. It's kind of useful for trust beyond our users. Then, except that, it's just a classic mint of NFTs. So we generate a token ID. The token ID will be the TalentLayer ID of the user. So it's an incremental ID. And the important part then is to know for one ID which address, which wallet is for now the owner. That's it. And you have here just the classic mint function. So here just the same as before, but no requirements for proof of humanity. If you have any question during the presentation, please don't hesitate. One point with proof of humanity is that the user can also activate it later. So you can mint a simple NFT first, and then when he registers in the proof of humanity protocol, he can go back in our system and say, okay, now I'm registered, and then we will update his NFT. It's the same with the profile data. We don't see it here, but yeah. So all data around the user, like the description, the skills he have, and stuff like that, are not stored directly in the contract. We only store the CID from IPFS. So here, basically from the front end, the user will fill a form presenting himself. We will upload all this data through JSON in IPFS and then get the ID of this IPFS file and store it in the contract. So anytime the user wants, he can come here and we call this function to update his information. I check which other function are useful. So just a function here to know for one address which ID is linked to him. And then, one point I don't talk about, it's when you mint an NFT, you choose an handle. So it's a string. For now, the requirements for that yeah, it's to have two characters at least, and maximum 10. I think we're gonna change that in the next update. But yeah, it's mainly the same principle. And of course, the handle should have to be unique.
What's the handle for? Is it for retrieving it later?
It's just the name of a guy, and we display it in the front end. Yeah.
Think of it like your Twitter handle.
Yeah.
Right. Yeah.
So we have some mapping to know which handles are already taken here, and a way to find for a TalentLayer ID easily is token linked. Yeah, we can talk just a bit about the recovery system. For now, we have just like a proof of concept of how we see it in the contract. So it comes with a Merkle system. I don't know if you are familiar with Merkle tree. The main idea here, let me jump just to a function. Yeah, that's this one, recovery account. So the recovery system, with the recovery system, we want a user to change the wallet address linked to a TalentLayer ID. And so to do that, the first mandatory things is that the user need to have the proof of humanity in his old address. That's the only way we can know that it's the same user behind, and that it's not a user who tried to sell his NFT to someone else. So we have two steps. We check if his old address is has been recovered. So we can know that by checking in the proof of humanity protocol, and we check if his new address is also now registered. So with knowing that, we can now, and a little connection more, transfer the NFT to the new wallet. It's the only way to transfer the NFT, because we all the classic function not exist in our system. We override the transfer from and save transfer just to do nothing. So you can't transfer it classically. You just have to do it with a recovery system for now. I think we see the main part for the first contract. Yeah, this one is kind of interesting too. So each NFT have a URI. The URI is useful to display metadata, and especially the image linked to the NFT. So here the particularity is that all the metadata are generated from the contract, and we don't need IPFS here. So you can see here that we first generate the image, and the image is finally SVG, and we will in the SVG, so it's kind of long. We put some dynamic data to put the handle of the guys. Yeah, it should be somewhere like in this line. So dynamically it's here. Dynamically, we write a text in the SVG to have a dynamic SVG like ENS did. I don't know if you know the protocol, but ENS did something like that. So we generate a SVG and we put all in a JSON format with just the name, the image, the icon, and a simple description. Like that, someone who go to any NFT marketplace can see his NFT, and you have at least one picture and some information about it.
So this build token URI, Well, what are we using it for? Is it for NFTs, for users, for user ID?
Yeah.
Okay.
It's just the main idea is to have a picture and some metadata with a TalentLayer ID. So it's not just in the contract, it's something you can see and you can show. So yeah, that's
Yeah.
it.
So
Later we can imagine a lot of stuff we can add here, like voice review rating or something like that can be put maybe in the SVG and stuff like that.
All right.
Yeah. The importance of having the image there is mostly for the way that people view NFTs these days. So when you log in on any platform with your wallet, even sometimes with different versions of MetaMask, you can see the NFTs that you have in your wallet. And if you do not have any image file associated with the NFT, then it'll just, show up as not having an image, which just doesn't really look good from a user perspective. So.
Right.
Yeah,
and I didn't get it. This link that you have, like w3.org/2000 SVG, is that
this one.
Is that standard image
Yeah,
for
it's
all?
a standard for SVG. Yeah.
Okay, so it just okay. So basically pulls that image from there each time. So we're not really storing any like images.
Yeah, we don't
That's
need
the
to
point.
store it, just generate like that, yeah, in line.
Okay.
And encode it in bus 64. 64. If you have, do you have any more question? I think we are done for this one.
I think maybe just one question to continue on that image thing is why is that on the back end side in the contracts rather not on the front end?
So
because go on.
Okay. So we need to have TalentLayer Core have all of the most important bits. And the front ends are basically just going to be looking back at TalentLayer Core. So something like an NFT and anything associated with the identity, the most important bits need to be stored on TalentLayer Core. Also, unless we had an image file embedded in the NFT, then it just wouldn't display on any third-party marketplaces. So it's just sort of part of the interoperability aspect of this. The image associated with it is stored with the NFT itself.
All right.
Yeah. Globally, it's always a good practice to have the image stored directly in the contract for the NFT because it's trustless. There is no server behind who can go down. So the user is guaranteed that he will keep forever his image.
Yeah, right. Yeah, I get it.
Martin?
It's like it increases the credibility of the visual aspect of the NFT. Yeah.
Roman, about the handle, they are only stored in the mapping or stored anywhere else where we can get it back. If I well understand, we could store on the marketplace by handle.
Yeah, so the handle is stored in the contract as we have some extra logic around it, as we have to guarantee that it's 100% unique for each one. So we don't have the choice to store it in the contract, but you can have it also. So you can check the after mint function. So here we emit a new event after each mint. So within it you have the handle. So we get that handle in the graph. So as you may know, we use the graph behind all our system to get all data from the front end. So we can see that maybe later how it works exactly. And so yeah, here we store the handle in the graph.
Okay, if I will learn the graph this week. If I well understand, the graph just get the event, the emit, and put it in cache, and we can use it after.
Yeah,
as we want. Okay.
Exactly, and we can say we can query anything we want around the user. So every data which is set in any event will be get by the graph, and we can then query any data quite easily by saying I want all the jobs of this handle, of this user ID, and stuff like that.
Cool.
Yeah. Any more questions for this one?
Well, that's all right.
I think that's good too. I'm also very fresh to the graph, so I'm a little bit like curious about where the graph comes in here. Like I don't.
I think you get the ABI,
like imported or anything. So how is it?
Yeah, the graph is not in the contract part. Finally, the graph will just read from the blockchain, get the data out, put them in a database, and then show API that we can use to get this data. That's how it works.
Just think of it as just an API. So it's allowing us to just very easily read from the blockchain through that cache, just via that API. So I think it would be great to have another call just to like dive deeper on the graph. So one of the people that actually built our graph is available to hop on a call and do like a deep dive there. So we could talk more about the graph at some other time.
All right.
Yeah,
that sounds good.
Just to show you one example really quickly. So in the graph, you describe your entity, like you will do it in any database. And then you say, okay, I will have this field. You have the handle here. So it's a string. And so you can declare like that all the data you have. And then you write script in JavaScript to explain how the system can get the information. So you write the code, to get the event, process it, and explain to the graph what do you want to save. So you can check this repository for more details, and as Christian's tell, we can have a talk with our expert, which is the best the graph expert I know.
Okay. Yeah, that sounds good.
So we can go now with the job registry. Service contracts is not an NFC. Its purpose is to handle the whole workflow of job creation to job ended. So here we will store the main information of each job we need. So for a job, you will have a status. So the status for now start with initialized. Then it will be confirmed when we found an employee. And when the job is done, it go to finished. And just in case the employee don't want to this job, we can reject it. So we store here the status. And then for each job, we have the employer ID and the employee ID. Every time we talk about an ID behind the TalentLayer ID, so the ID of the NFT we see before. One important thing is we have to store who initiates the job creation, because in our system today, the employer and the employee can create the job. It's not only the employer. So like that, we can do some step in the workflow by knowing who initiated it.
Yeah, I have a question. Quickly here. Employer ID and employee ID. Why are these not TalentLayer ID NFTs?
Yeah, it is. It's the idea of the NFT.
Okay, they are.
Yeah.
Mm.
Yeah.
Okay, so
Here,
you just when you fetch those NFTs, you extract the int from it, unsigned
Yeah.
integer. Okay.
Yeah, you will see later, but yeah, that's as simple as that.
Right.
And then, like we will do for the user, we have all the job information, description, skills needed, etc., who are stored in IPFS, and so we stored only in the contract the URI of IPFS.
So sorry, one more question. The initiator is either the employer or the employee, or can it be a third party as well?
No, it's one. Yeah,
it has
one
to
of
be
them.
one of those.
Yeah.
Okay.
So here you can see the event with all the data information. So this is really useful again for the graph to query easily all job created by someone, all job by status or something like that. So now we can, go with the job creation. So you have actually two functions. Yes, so the creation when you are an employer, so the more usual one. So here an employer can come and say, okay, I want to create a job. We will get first is TalentLayer ID. So just by getting from the TalentLayer ID contract the ID of the message sender. So automatically with this line, and then if you go here, so we have some check just to check that the employer and the employee is not the same person, and of course that's the TalentLayer ID is well validate. So just by checking that is more than 0. And then when you create a job, so you give the job data array, so we have a little check on that too. And then we store all this information in the mapping and emit the event. We also return the ID, which can be useful. And so it's as easy as that, and quickly the same for the employee. Just here it's stored differently, here the sender ID. Yeah, it's not the same order between this one and this one. It's how we can know it's the employer or the employer. And yeah, that's finally the same. And so after that creation step, so the status of the job is initialized, and we have several functions to update the job state. So the first one is the confirm function. So here we let the other person who don't initiate the job to confirm that he want to work with the other person. So like that, we check like always that the user who call this function has a TalentLayer ID that is well part of the job. And then if all the requirements are set, we can upgrade the statute to confirmed. So now the people are agreed to work together. If it's not the case, the user can also reject. It's quietly the same, so but at the end the statute is rejected. And finally, when the job is done, anyone or both can call the finish function. So yeah, you have to be one of both until we check that the statute is well confirmed before going to finished, and then the job go to finish. And now the job is open for review only if the statute is finished. And that's it for now for this contract. We'll make some evolution in the following days on that to add another status to let an employer create a job, open it to the market, and wait for someone to be interesting or to be chosen by the employer. So it will be some update on this function, but the main idea will be quickly the same.
One question, Roman. If it's during this part, at the end of the finished job function, that the escrow contract starts, that if the emit job finished goes well, it starts to pay. It launches the escrow contract to pay the developer. We have to connect to that.
Yeah, it will be a bit more complicated with the escrow system because where the two parts are to be agreed on that the job is finished and well finished. But in the idea, yeah, we will do the job here, with the end job system here.
It's kind of multi-signature, multi-sig. Like
yeah, they have to be agreed on one thing. Yeah, yeah, and we need both signature to then send the money or stuff like that. Yeah.
Okay.
Any more question?
Just one final comment on the escrow. So in addition to having the release of the escrow happen like towards the latter part of this contract, when we implement the escrow, in all likelihood, we'll probably have some sort of additional status update, like job funded or something like that, just so we can reflect that in the job that the escrow has been funded and initiated. But yeah, we'll be defining some more of that once we jump into the escrow design.
Yeah, exactly. So that's it for this one, and we can jump in the last one. So the TalentLayer review. So here it's a simple RC721, so an NFT. The main important part here is that the NFT is not linked to a wallet like all NFT in the place, but it's linked directly in the with the TalentLayer ID NFT. So like that, if the TalentLayer NIT owner change with the recovery system, all his TalentLayer review go and are migrate with them. So I will show you how this part works. Yeah, and that's as simple as that. So that's here. So to know an owner of a token of a review, we check the owner of the token ID of the TalentLayer ID linked to this NFT. So just this line do the trick. Then it's actually a simple contract NFT with some custom stuff during the mint. So let's jump to that. Yeah, this is this one. So from the front end, we call the add review function. So it's the function who handle the mint. Here we have to know which job do we want to review. Like always, we have an IPFS URI to know the extra data with the job. So with a review. So here it will be the description of a review. And we also pass here the rating. So the reviewer have the choice to rate someone to 0 to 5. So then we get the job from the registry. We check, of course, that the job is well finished, so we can have some review on it, and that the one we call the function is well a part of this job, so the employer or the employee. And then we have some check here to revert in case someone already minted an NFT review for this job. And if it don't, and if this code don't revert, it will go to the min function. We've got some mapping also interesting to get easily some minted, to know for an NFC if an employer and a job already minted, and same from the employer. And then the mint function, it's quite usual. So balances, so here someone can have more than one review, of course. We store the URI and we emit an event with all data and use it like always in the graph. Of course, these NFTs are like soul-bound NFTs, so they can't be transferred at all. There is no recovery system, as all the recovery system is in the TalentLayer ID contract. So here you just can't transfer it. And that's it. All the extra line of code.
This whole contract is an NFT. It's not just a normal contract.
Yeah, it's an NFT. Yeah.
Why is it an NFT? I mean, if a contract has its own, address and everything, it's still unique. What advantage does it have from being an NFT?
Because each review has its own data linked to that. So an NFT helps to do that by saying, okay, we mint a review. It's the review number 1 for the job X, and with this extra data, and like that.
Okay, got it. You can have unique data with a contract that is not an NFT to have like specific data to each one. Cool.
And like that, you can see that at the end in the process, if I am the employer, I will call the add review, and this will send the NFT to the employee. And now, just in any wallet or marketplace, show his reputation with that, and he owns his reputation, and that's the main point of the protocol.
Okay.
So the NFT being soul bound means basically that you can transfer it, more or less. And how is that? Where is that check in the contract?
Yeah, that's it. You can transfer it. So that check is here. Is it? Yeah. So here, basically, when someone tries to call transfer, we do nothing. So it's an override from the classic implementation.
Right.
And so the soulbound is finally 2 things: the fact that you can transfer your reputation, but it's linked directly to your TalentLayer ID, that you can't transfer easily, but you can recover with our system.
All right, so being respectful of time, I wanted to ask if you all have like 15 minutes more, so going to like the bottom of the hour.
Yeah, works for me.
I'm good.
All right, cool.
Good.
So I was thinking, Roma, maybe we could just very, very quickly maybe do like just a very quick intro to the graph, and then show in the dApp how it interfaces with the graph, and then just leave like 5 minutes for work process for me.
So yeah, I'm just playing with the graph, but just to show you how powerful it could be. So this is the endpoint of our graph system. Here, like you see, we declare some entities. And so for the entity user, you can say, okay, for all our user, I want the handle. So you can see all handle, and you can check and you have all possible stuff. So you can have the ID. You can know if the user activate the proof of humanity. Can have his rating also, basically. And like that, as easy as that, we query all the information and we use it in the front end. The thing that is really powerful is that you can then tell, okay, I want another entity, which is the job, and get the ID. And then you've got all of that just here. So you can know that for this user, is the employer for the two jobs here, and this one, and etc. And like that, you can query any data we build in the graph.
And you pay per each request?
For now, it's free because it's not fully decentralized, but the graph are in progress to decentralize and install some payment on the query.
Yeah. So basically, starting in January of this year, we, well, before January, we're going to have to migrate our current graph implementation to live on Filecoin as opposed to living on the graph's like self-hosted service. So right now, the self-hosted service is free, but once we move on to Filecoin, we'll have to start paying fees. So it would be on a query basis, just like most APIs, but it shouldn't be too terribly expensive.
But why move to Filecoin?
So the graph is, rather than the graph being a place that stores data in itself, it is more so a way of interfacing with blockchain data, sort of like a standard. So you can have a graph implementation on Filecoin, on IPFS, on any distributed storage network. Right now, because the graph is still a very new protocol, in order to incentivize people to use the graph, they're currently offering their own sort of storage option where they store it for you on a decentralized file storage platform and they cover the fees for you. So that's not going to be forever. They're going to be getting rid of that starting in January of next year. And that's why we need to migrate over and host ourselves.
All right.
I just continue to play a bit with the query, but as you can see, you can easily query the job, get the URI from EPFS. So that's all kind of query we do in the front end in the React app. And you have all the information we want here. And you can also use condition here. So we can say, I'm not sure the syntax. I'm not sure the syntax, but you can have like an SQL and say, okay, I just want for the user one, and query stuff like that.
All right. And is that something that they're fetching from chain or from servers, from cloud servers that they are hosting? Because
now
it's decentralized, right?
Yeah, for now it's from server they're hosting, and they get the information on chain. So it's a cache.
Okay.
Basically.
Right.
And then in the decentralized version, the cache will be on Filecoin or wherever else we decide to store it.
All right.
So just to complete that, we use the graph for all non-crucial information. If we need something that we want to be sure to display on the user front-end part, we have to get the information from the chain. For example, the ID of this TalentLayer, we have to get it from chain, and to complete the data, we go with the graph.
So why include these? Is it for decreasing gas costs?
It's
Like, why not store
not
it
really
directly
for
on
the,
chain?
oh yeah, we can't store all of that on chain. Yeah, it's for gas cost. Yeah.
Mm. But it's just like username and it's the reviews, right? That takes on.
Yeah, it's the very bulky bits of text that we're storing on IPFS. So, for example, like an entire paragraph of review data,
Right.
as opposed to just a handle. The handle is stored on chain.
Yeah.
Like keyword URIs are stored on chain, things of that nature.
Mm.
Is it okay for the graph part, or you want to check also the code maybe?
Mm.
That's okay for me. Anyway, I will take 1 or 2 days to deep dive in the code, and yeah, I done with Notion list all question, and if Roman you agree, we can make a one-to-one or with Emil or Ilya just to focus on really specific parts of the contract.
Yeah, sure.
Nice.
Cool.
Yeah, I also think that sounds good. So, but I guess the interesting part is also that basically it's the graph is not coupled with the contract in any way. Like, it's separate, right? And you just use scripts to upload information to the graph about what kind of data structures you're using so that they can be used later to query them through the APIs.
Is the graph querying
Exactly.
blockchain directly?
Mm.
Is it interact with smart contracts, or is it like you download, you cache the data, and then you query the cached data?
The graph gets all the information from the chain directly.
Cool.
Mhm.
And what is the query language the resolvers are written with?
You mean this language?
No, this is GraphQL. I mean the resolvers that actually pull the data. What are they written with? Do you have
JavaScript.
access to it, or are you using a service?
It's written in JavaScript.
Ah.
Mm.
And it uses our function like that, for example.
Okay, cool.
So if
yeah.
we would use Filecoin to store stuff, could we still use the graph for like querying?
Yeah, so the interesting constraint of the graph is, as of right now, they do not have support for decentralized file storage for like the thing that you are trying to query from. So right now it can only query from blockchain networks, although they are currently working on building tools to allow querying from IPFS and Filecoin. So that's actually one of the reasons why we had to architect things the way that we did. For example, we probably would have stored keywords on IPFS because keywords can be like, you know, a lot of data there. But because we need to be able to like parse and search that data very easily, we had to have that on chain, which is why we had to design a URI system where each keyword has, you know, some sort of number associated with it, and we only store the number to try to like conserve on space.
Right.
Cool. Well, I think that's good on the graph. So just last thing, I think it might be cool to look at like maybe one of the front ends that pulls stuff from the graph, just to like sort of tie everything together.
Okay. Do you want to make a demo?
Yeah, we could do that. So let me bring that up. 1 moment.
Yeah.
And this would be a good opportunity to talk a little bit about the Indy demo as well.
Yeah. Also on the contract code, just during the prepare, you can check the test. So we write the test during an hackathon, so we can do better, of course, to have a more big coverage, but it covers all the main stuff and main workflow.
So This over here, all this is on GitHub, but this is basically a sort of demo UI that works through a couple of the features that we've built, including creating the identity, leaving reviews, creating a job, things like that. All right, so going to the admin center. So over here, all of this data is being pulled from via the graph. So this is sort of an aggregated summary of the average rating from reviews. That math is just handled on the front end. And then these are jobs that were completed by this handle. Of course, all of the information we have in here is just sort of spoof information that Romain and I and some others have plugged in as we're testing out the system. But as you see here, like if it reads that the status is initialized, it will prompt me with specific things like confirm job or reject job.